before we go deep into the closures, so I think it's better to revise some concept of the JavaScript. The first one is the block scope. Before the ES6, JavaScript has the block scope syntax, the curly braces, but it does not create block scope. Only the functions can create a new scope within the global scope. After the ES6, the block scope is introduced along with the block scope variables let and const. The second thing, after function exit, the content of its scope also destroyed if there is no any referenced in the global scope. And the third one, the nested function, the function that define inside or within another function. Here you can see the function say hide by takes two arguments, first name and last name. Inside of it, we have another function called get full name. It will return the first name and the last name. So the next is the execution context. It's a concept used by the ECMAScript specification to track the runtime evaluation of the code. A new execution context is created after invoking a function, and it has own scope. So which is this local variable environment holds all the argument passed into it, and also the declaration made inside the body. So the next thing is the global context. When a program is started, the JS engine will create a global context. It is similar to other context, except the global context will never die as long as the program runs. Hence, its variable environment won't get exposed by the garbage collector. The global context, which the code is first executed, or when the flow of the execution enters a function body. Eventually, the architecture of the JS and the JS is a single-threaded language, so it can execute one context at a time. But the context can be suspended by another context. So here you can see in the picture, in the bottom we have the global execution context. Top of it, we have the number of execution context. So the execution context will remove from the top of the execution after it's completed. And we have the closure. So here you can see it has, there are three functions here. So G and H are nested. The function H has the references to variable X and Y, which those belongs to the outer functions. So the nested function or the inner functions form a closure, and which will inherit the arguments and variables from the outer functions to store the variable that after the function is returned. Closure function have three scopes. One is the global. Second is the local scope. It holds its local variables. And also it has the special scope called the nested functions. Lexical scope. The lexical scope is nested, and nested functions have access to the variable declared in the outer functions. So the lexical scope is theoretical specification which every running function has an internal object called the lexical environment, which contain two parts. The first one is the environment record, which contains all the local variables and its properties. The second one is the reference to the outer lexical environment. Here you can see the global environment has the function foo, and the function foo has the function bar. So each environment has its environment record and the reference to the outer lexical environment. So the bar environment has the property of z, which holds the value 15, and also it has the outer reference to a foo environment. If we check the foo environment, it has the property y with the value 20, and also it has bar, it's a function, and also it has the outer reference to the global environment. The global environment also the same. It has the environment records, and the outer reference is null because the global environment has the outer reference to null. So this is the simple example for the closure. So here you can see the variable instance is pointing to the function m, which is returned after execution function f. Within the function m, there is the reference to x. The x is the variable should be alive or remembered because it is indirectly referenced in the global scope. So here you can see the my double variable contains the pointing to the function m, and the which is returned after executing the function f. So the function m creates a closure here and store the property x with the value of 2. So calling the my double function here with the value 10, which is we are passing the value to the y, so it holds the closure with the value of the property of property x with the value of 2, and it will return 2 into 10, 20. Same as for the my triple also. So we have a question. So can anyone tell is this a closure or not? Anyone? This is not a closure because the function f runs and then function g runs, and both function exit. There is no active reference from the global scope to function g. And we have the multiply nested functions. As you can see, the function a contains b and the function b contains c. So both b and c form closures here, so that B can access A, and the C can access B. So C can access both B and A. When the code wants to access a variable, the local environment is searched first, then the outer one, then the more outer one, and so on till go to the global one. If we check the scope here, it has two closures, A and B, and also it has the local scope, and also it has the global scope. And also we can see the call stack here. So it has the global context, and then A and B, and top of the stack it has the context C. Okay, so we have a real-time problem here. So we want to store a counter of the screen rendering. So there are two solutions. One is having a local variable inside the function and calling it. So every time we are calling the function, it will create the count with value 1 and will increase by 1. So this is not the proper solution. And we have the second solution, which we can use the global variable. And we have the function called display. We can increase the count by calling it, but it will work, but there's a problem. So we can access the count variable anywhere in the global scope. So if we set the count into 1000, so it will, so that means the count variable can access or modify it everywhere. So the count will be wrong. So how we can solve this issue properly? So let me share the screen. So we have here the function display function, which contain the count, and it also have two functions. One is increase count, which will increase the count by 1, and also it has the get count method will print the current count value. So after executing the display function, it will return some properties. So which will return the object which contain this increase count and the get count. So if we check the get count, so we can see a special scope is there called the closure, which contains the count 0. And if we go to the next line of the code, the count will increase by 1. The new closure will be created every time when we run the display function. So the display and display2 has the different closures. Here you can see it has the different properties. So the current count value is 2, but in the display functions, the current count value is 3, like that. So that's how we can solve this issue. And we have the uses of the closure. First, we have the data privacy. The enclosed variables are only in the scope within the outer functions. It cannot access the outer data outside scope without the privileged methods. And also we have the partial application, the stateful functions. The process of applying a functions to some of its argument. The partially applied function get returned for the later. So this is what we discussed earlier. For the encapsulation of the data hiding, we have two argument passed to the function f. Inside of it, it has three functions, a, b, and c. The function a and b are exposed to the global by the show public and show private methods. But actually here, we are not accessing the private variable directly. So we have used a privileged functions b, which will invoke the function c. So if there is no privileged functions, so we cannot access the variable from the outside. And finally, if I have the issues and performance considerations, the variable declared inside the closure are not garbage collected. And also too many closures can cause the high memory usage, and also it can slow down the applications. Yeah, so that's all for the closures, and I'm hand over the session to Aman to continue the modules.
Okay, so my part is modules. Let me explain what modules is. Right. First of all, let me give you a little bit of background on the modules. So ultimately, like modules in JavaScript are just files, right? So they are files, but we have split into different small part of files. So that's what modules are actually. So then why do we use modules? Right, modules provide these kind of advantages. One, it gives you code splitting. When I say code splitting, you can like namespace everything and provide each part of your application in a different context, like different files or different directories. So you can organize your code and set up the application as you want. So that's one thing module gives you. And the maintainability. So rather than putting everything in one file, you get to choose what to put where, and so you know where to look for when something is going on or when you want to search for something, right? So you can achieve that with modules, and it is easy to test. So when you have different files and it is modularized, so what you can do is you can test that part individually apart from other files. That's one thing. And sometimes it gives you performance. When I say performance, like it's like allowing you to import what you only need, right? It's not giving you a scope pollution or something. So you are not importing something that you are not going to use. So that's gonna come in handy when you are bundling and stuff. So let me give you why we come to the modules. Like why did people start using modules? So earlier, like you can think of like 3 or 5 years ago, like we had JavaScript programs, but it started pretty small. So we used them in like isolated scripting task, right? So we didn't use it much. So when we used it was like to like provide a small bit of interaction, let's say, for a web application. So those days the web applications were powered by mostly PHP and stuff. So we used a little bit of JavaScript to give interaction. But now with the introduction of Angular, like React and Vue, these kind of front-end frameworks, we are using like entire application, like we are building entire application in JavaScript, right? So everything is in JavaScript. Some of us, like even I don't know how to link a JavaScript tag now, so I had to look it up on the Google. So everything is JavaScript. So we are no longer using the script files and normal standard JavaScript, right? So and the other area where we using is like Node.js. So Node.js had this module system from the beginning. So it's the one introduced this module system. Then we are using this front-end frameworks such as React, Vue, and Angular. We are using the module system there. So that's where we are using the modules. Then where is this module available right now, right? So Node.js, as I said, it's available. But when we have to use it in other places, we had to use tools like Webpack or Babel to compile the module stuff to like native code. Now we don't have to do it because most of the browsers natively support it, the modules. Mine support it anyways. I don't know about yours. Right. So let's see. Modules are pretty hard to explain, right? So in the next 6 hours, we'll be creating a full stack e-commerce website to explain the concept, right? No, just kidding. I'm going to explain it in VS Code. So let's go to the next thing. So here is what modules look like in our overview, like let's say high level point of view. So earlier, if you look at the left side, we had a script where we put all the functions, all the logics and everything in a single file. But with the modules, what we do is we split code, right? So we put the function A in a different module, function B in a different module. You can think of that as like React components, let's say. So ultimately, we will be importing all those into one single file. That's what we do. But we have this option to split these things into different files. That's what modules gives you. All right. Let's give this a shot, right? So we can see what are the difference between modules and standard script. You can take a screenshot and read it, but I'm gonna be here for a long time because I'm going to explain it in code. Let's go to VS Code. Right. So yeah, I have a browser environment here. So what I'm going to show you is first how to create a module, right? So some of us don't know how to do it, so I'm going to explain it. So we have this normal script text, right? Let's see, whatever we can put here, let name equal to something, something. But if you want to make this a module, it's easy. What you do is you put type equal to module. So now this is a module. So as simple as that. So let's see what are the differences between the modules and standard script, right? So when I say standard script, so this is what standard script, then this is the module. So let's see. First one is modules are deferred automatically. So when I say deferred, let's say an example, right? We have this h1 with the ID of main, right? So if you want to, let me put this in the top. So I'm going to put it here on the head script. This is a script, a normal script. So in the normal script, what I'm going to do is I'm going to go there. Oh boy, it's going to be a this file, right? I'm going to do is I'm going to console log that element, what I showed you now. What you get here is null, right? You all know the reason because we are loading it in the head, so we haven't loaded the body yet. So if you want to do that part, what we did was earlier we used a defer statement, right? So we did defer and now everything is good. We get the h1. But with modules, you don't have to do that. So what you can do is ultimately, right, let me show you. You put the module here. I removed the defer keyword, right? So still it's working because it is a module. So now we have access to the defer automatically. That's one difference. The other one is strict mode. So modules use a strict mode automatically. So when I say strict mode, let's see. First, let's create a normal script. So here, x is assigned to 3.14, but x, what is it? X is a let, is it a const? We don't know, right? So, but in the browser, it's not giving you any errors. So the reason is this is a normal script. We can do whatever the hell we want. But if you put modules here, like let's say type equal to module, it's going to give you an error because it's using the use strict mode automatically, right? That's one difference. The other one is modules are executed only once, right? When I say that, let me import this again, right? I'm going to uncomment this, right? You can see the console. I'm a normal boy, so it's executed, no problem there. But if I do this, what do you think will happen? Right, it's going to console log this many times, right? So what I'm going to explain you now is let's import this one as well. This is a module boy, right? You can see the module, but this is a module. But if I do this now, it's not going to do that like the normal script because it's evaluated only once, no matter how many times you import it. So that's one difference. Then another difference what we have with modules and normal script is this keyword, right? So no, not the one. So if you see this, I'm going to console log this keyword. The normal script, this refers to in the browser environment anyways, this refers to window, right? So if I save it, it's going to give you the window. But what happens if you put type equal to module? Anybody knows this? Okay, I guess not. So if I put this, we get undefined. So in the module environment, this refers to undefined. That's another difference. Then we have a main difference in the scoping, right? So let me explain the scoping part. So if you put this one, this is a normal script. So let's say this is a global scope, which is a string global scope. When I console log it, it's going to give it no problem. But let's create another script, which is a normal script. So what happens if I put this? But it has access to this variable. Let's see. Because ultimately all these scripts are like bundled to one script. So we have access to whatever we define here, we have access here, right? But what happens if we put a module here? Does it have access to that? Let's see. No, it doesn't. But why is it not giving you an error? It should give you an error. It's probably because I'm using the right. My bad. Because it has access to the global ones. So it has access to this one as well, even if it is a module. That's my bad. I'm sorry. Right. Let's see this example, right? So what I'm going to create is this one. So in a module, I'm going to create a module scope variable, right? So this has access here. But if I try to log it out in a normal script here, it's going to throw an error because we don't have access to the module scope in the global, not in the normal script. So that's another difference. Then if you want to get access to this module, what you do, like normally, like from outside the module, let's say we have another module. If you want to get access to that module, what you do is normally you can do this. You can attach the module scope to the window object, which will make it globally available, right? So now you have module scope, but if it won't work in this normal script, it has to be a this script. So now you see both has access to this, right? This is one way of exporting variables from modules to modules, but this is not a good way. It's going to introduce you a lot of pollution in the scope. So that's a bad idea to do that. I'll show you how to export and import later. Okay, so that's one thing. So let's go to the presentation again. So those are the differences between the normal script and the module scripts. So exporting features using modules, right? So whatever we create inside the modules, it is not available to the outside world, right? So ultimately we want to be using some kind of mechanism to export variables to other part of the modules, right? So we have this keyword features, right? Wait, features in modules are made available to other modules with export keyword, right? That's how we export the features from one module to another another module. But there are two types of export. One is a default export. One is a named export, right? We are going to export everything. So that's what this says. Then importing. What about importing? So when you import, you use the import keyword. And you guessed it, there are two types of import. One is default import, one is named import. Right. So let's go back to some examples again. What I'm going to do here now is add a script tag source path.js. Right. This file I have created already. If I go here, I'm gonna comment it out for the sake. Let's create a function, right? Inside this function, this is the function that will bring world peace, right? A very important function. So we are spreading love here, no pun intended, right? So it is going to console log something. So how do we this is a pretty important function. So some other world like Jupiter or something also need this function, right? So how do we do that? How do we export this function to other worlds? So what we do, we put the export keyword here. So now this function is available from this module to other modules as well. Let me get rid of this error first. Right. So one way is this is the named function export. So as you can see, like we are directly exporting this function. There is another way that we can do, which is the default export. If we do this, this is the default one. So we can only export one default function, like one default export from one module. But you can export any kind of any amount of named export, right? If you will. Then what you do in the other parts of the this one, you import it. I'm going to comment that out. So how do you import that function? You import it like this. So this is the default import. Wait, not defined. Wait. Guys, help me out here. What am I missing?
I think the function name,
Anybody
right?
knows? I'm trying to export this function.
Yeah, but your function name is different. If you go to auth.js, it says export.
Right.
Yeah, yes.
Right. Yeah. So this is the name import. Right. So now you can do this. Right. Thank you. So you can do the name import or the default import. It's going to work regardless, right? It's not going to give you an error. Like if you really want, you can execute that function from let's say this is see what is here, but that's not the point. So we showed you how to do the default export, how to do the named export, right? Then we can do something else when you are exporting. Let's say you are exporting from the named export, you can do like this, or else you can do this syntax as well, right? So you can export it everything in the bottom. So this is only exporting a named export now. So you have to bring it here. Now, if you want to rename something, like when you're exporting, you can do something like something. So now it's no longer exporting this function. It's exporting function called something. Right? So you can import something from here and execute it. Everything is good. So that's one way to export. So when you are importing, there are a couple of importing, right, techniques. The first one is this syntax. This syntax is useful when you want to import some like side effects, right? This is not really have to do with like some function exporting or anything. So as you can see, this is giving you some play music rain effects from the effect.js file. So when you have conference, it's good to have music in rain effects, right? So what I'm going to do is I'm going to import it on the top. So keep this. Then we show how to do the default import, right? Then we show how to import named imports and everything. Then let's see how to rename when we are importing, right? So let's say we are importing this something, import something, oh shit, from earth, like you saw that we can execute this function with some value and it's going to work, right? So if you, let's say you already have a function something here, so a function something, but now there's going to be a problem because we can't have two functions with same name. So what I'm going to do is I'm going to read this function. Another thing, right? You have two different functions. Now everything is good. Right? That's renaming when you are importing. Let's say you go to this file. You can see the right. So I lost you there. Anyway, so let's say we are exporting a lot of things from here, right? We are exporting the name, we are exporting the age, we are exporting this function and everything. So now what we are going to do is we are going to import everything from here. Name, what else? Age, right? This is a lot of things. Sometimes what you can do is you are importing everything from here now. So what you can do is import everything as single file. So how do you do that? Import everything as something. Now this something has access to what? All the files, all the variables that are exported from here. So that is one way of importing. It is importing everything is in a single file. Right. So let's see something about namespace. When you use this module, right, export and import, we have this importing this file. Now this thing we in as well. This is net. Wait. But this same now this function. Now what I'm going to do, I'm going to the same and here, get everything here from here, here, right? Now, what we were discussing is like you can namespace these things, right? So now I have namespace Jupyter in one file, and I have namespace Earth in another file. So when you are importing, what you can do is import these constants. But even though this has the same function, everything, so when you import, let's say Jupyter from Jupyter, right? Then Earth from Earth, right? Now you have access to these other variables, right? Same variables from the Earth and Jupyter, but it's namespace. So there is no correlation between names. So even though they share the namespaces, what I mean is like the namespace is a concept from other language like C#. So there are a couple of optimization we can do from the modules perspective, right? So one, you can use the dynamic module loading feature, which is available in all the major browsers now. So what you do is you don't import it on the top. Whatever you are importing, let's say you have an expensive function that is going to calculate, like it's going to take some amount of time. So if you are going to import it, it's going to give you a lot of overhead, right? So what you do is you don't really need it until you need it, right? So let's say this function only runs when user clicks some button. So what you can do is there is an import syntax. So import, I know you guys know, like import is a function, right? Normally import can be a function. So what you can do is import modules on the fly, like dynamically. So which will give you a promise. So then the result will be the modules. So whatever the function that's available inside the module, you can get access to that. So rather than importing on the top, you get it when you need it. So that's one way of optimizing. Then we have things like tree shaking, right? Tree shaking is a concept like it's form of dead code elimination. Like you eliminate what is not needed from your application. But nowadays we use this build tools like Rollup, Webpack, and everything. It does it for you, but there are something that you can do, right? Importing only what you need. When I say that, you can think of this way, right? We all use Lodash library, right? So when you want to use Lodash in some file, we are not going to need all of those uh, things that is shipped with Lodash, right? So mostly let's say we are using the omit function. Uh, Normally what we import is import underscore from Lodash, right? So when you do that, it's going to give you the entire package, Lodash package. So it's around 71 KB or something, right? So sometimes you will do this, you import it named import, right? So what you do is you import in the parent like curly braces, you import omit from the Lodash. So you think some like it is going to give you a performance boost, but it is not, because it is going to import everything, but you are like taking only the module you need. It is not also the best solution. What you can do is Lodash is modularized, right? So what you can do is import omit from Lodash slash library or something and omit. So when you do that, so it's going to only look for that particular function, right? So it's around 20 KB or something. So you are saving there 50 KB or something. So that's one thing you can do. But other than that, you can use the web like bundlers to do the work, right? So it will eliminate all the dead codes, unused variables. Even you can set up for CSS to purge the CSS and everything, but it is not in the scope of these modules. But anyways, that's there. But there are something you can do. That's what tree shaking is. So from then, that's it. So that's it from me.
You're talking about that dynamic import feature, right?
Right.
So,
Yeah.
I don't know whether this is possible, but if you can show us the syntax, that would be, I think, helpful.
Right. I can show you the syntax. Let me share the screen. I'm really afraid to share the screen because something is going wrong with the connection. But let me know if you can see the screens anyway.
Yeah, we can see.
Right. So this is the expensive function I was talking about. Here, nothing is going on, right? This is a function that is console logging everything. But let's go here to the index.html. So what I'm going to do is create a script tag. Right. We have this button. Where is it? This button with the ID of button, right? So normally in the module, it has to be a module anyways, no? If you are going to import something, type equal to module. Normally what we do, we import, we can't really do it here. It has to be a separate file, right? Oh, can we do it? I haven't tried it. Import from expensive function. No, we can't do it, right? We have to create a module, is it?
Yeah, I guess so.
I don't think we can do it. Let's see. Yeah, we can do it. Right. So this is what we do, right? Normally. So But we don't really need this function unless we are going to like, let's say, use it. So this is an expensive function. We are going to use it when we click this button. So let me get the reference to this button. If I can type properly, document.get element by ID. This is button, right? So let's add an event listener, which is a click listener. Okay, when I click it, let's see if it even runs. Right. Now let me go to the browser. Right, it runs, right? So it works. But let's say you want to use this function here. So what you can do is use import as a function. So how do you import as a function? Import can be a function, as I said, import can be a function, you can invoke it. So what you do is import the expansive function, this module on the fly dynamically, which is a promise. So you can do the dancing syntax, which will give you the module back. So what you can do the module dot. This is JavaScript, guys. We are so used to TypeScript, so I'm expecting the type completion. It's not working. So you can do this. Inside the module, you have this function, so you can execute it rather than doing this. Right now, what I'm going to do is I'm going to click the same button. Let's see if it runs. Yes, it runs. So we are only loading this function when we need it, right? So this is what I explained when I said module, like dynamic module import. Does that answer your question?
Yeah.
Right. Any more questions, guys? For Suhail, maybe?
So maybe this is a stupid question, but so basically this will only work. This will only import when we click the button, right?
Right. Yes.
So other than that, it won't import this function.
No.
So okay, so the only advantage is if you don't click the button, it's not going to use it. That's it, right? It's only
Yes.
like the size, only in the size, right?
Yeah. It's just a performance boost. Like when you are ultimately this button is the only thing that is going to use this function, right? In this scope, so it's no point using it there. And like when we need it, we use it. But it is a normal function. It doesn't make sense to like load it this way. Since this is an expensive function, we have to do it this way.
Okay.
Right.
And in addition to that, if you don't like the syntax, since it returns a promise, you can use async await, right?
I think so. Let's try anyways. It should be possible. Okay, it should be like, it should be possible. Let me click this button again. Yeah, it works. Yeah. Is that all, guys? The question?
So we can wind up the session now. Next week we will have the technical discussion. Hope we can see you all there. And thank you for joining, guys.